Hi there, grade 11s. I'd like to discuss the following few examples. They're all concerning static friction. So let's move on. Right, the first example says a box, mass 80 kilograms, stands on a floor. Calculate the size of the minimum force needed to get the box to move. Now, if it's wise to always draw a diagram showing the situation. So this box has a gravitational force, Fg, which can be calculated by using mg, mass of the box times gravitational acceleration. And as the normal force, Fn or n is the normal force. We use n or Fn. Right, so the mass is 80 kilograms, and we can calculate the gravitational force, 80 times 9.8. Gives us a force of 784 newtons. Now, unless there is an applied force at an angle, the normal force would be equal to the gravitational force in size or magnitude, if you want to say that. And I know that the maximum static friction would be equal to the coefficient of static friction times the normal force. Oh my, I have forgotten something. This thing is standing on a floor, and they want us to calculate the size of the minimum force needed to get the box to move. So what must the applied force be in this case? So the normal force will be 784 Newton. They haven't given us anything for us in order to work out there we are. The static coefficient of friction is 0.3. Oh my. I wonder whether I can move all these things down a bit. There we go. So I thought there's trouble here. If we don't have the static coefficient of friction, we can't calculate the maximum kinetic force, the maximum static frictional force. So it's 0.3 times the 784, and there we go. It will be 235.2 newtons, and it will oppose the motion or the force applied on the object. Right, let's go to the next example. The next example says A box resting on a surface experiences a normal force of magnitude 30 newtons. The coefficient of static friction between the surface and the box is 0.34. What is the maximum static frictional force? It's always wise to draw a diagram of the situation. So here the box is standing on a flat surface. The normal force experienced is 30 newtons, so it's given. There will be a gravitational force. I don't have to worry about that at this point in time because the relationship between the maximum static friction and the normal force is that it is equal to the coefficient of static friction. So Fs max is us times Fn, and I've got all the information to calculate this, 0.34 times the 30. 30 times 0.34, that gives us 10.2. So whenever the applied force gets to 10.2, after that, the object will start moving. I hope this helps. I'm going to do the next example in the next video. Happy watching.